Let's take a look at a second example. In this particular situation, what we're going to have are problems that involve square roots. So I'd like to find the domain of the following algebraically. Now recall when we have a square root in our problem that we cannot have a negative underneath the square root, that our radicand cannot be negative. So in each one of these cases, what we're going to do is we're going to, in essence, set the item that's inside the square root, under the square root, greater than or equal to 0. We can take the square root of a 0, so what we want to do is set it greater than or equal to 0. So our first example is fairly straightforward. D at x is the square root of x. So if we go to do this, we take the radicand, what's under the radical, set it greater than or equal to 0. We get x is greater than or equal to 0. Not really much solving to do, just kind of gets us in the spirit of the problem. So if we actually wanted to write this out in a little better notation, what we might do is draw ourselves the picture. So it's x is greater than or equal to. Since it's equal to, remember we can fill in that dot. Greater than or equal to, of course, is everything going off to the right. And so if I were to write this in interval notation, notice that I'd be on the left 0, right infinity. Infinity always gets the parenthesis. In this case, we equal to 0, so we get the bracket. Let's look at b. Our function here is e of x is equal to the square root of x plus 1. Set the radicand greater than or equal to 0. So we get x plus 1 is greater than or equal to 0. Therefore, x is greater than or equal to negative 1. I wrote the domain using inequality notation as well as interval notation. And by now, you should be getting used to the interval notation piece. Example C. F at x is the square root of 3 minus 4x. So again, we set the radicand greater than or equal to 0. So 3 minus 4x is greater than or equal to 0. Now be careful when we solve this. What I decided to do was subtract 3 from both sides. So that gives me negative 4x is greater than or equal to negative 3. And to solve this, we divide by negative 4. Remember, we reverse the inequality symbol when we multiply or divide by a negative number. And so what we end up getting now is x is less than or equal to 3/4. And you could actually check this. Check a number less than or equal to 3/4, and you'll notice that we actually get something that is in the domain. So if I pick 0, which happens to be a nice number, less than 3/4, and substitute that into the original function, I'd get f at 0 is the square root of 3. That is a valid real number. But notice if I pick something that's not less than or equal to 3/4, like say 1, I'd get 3 minus 4, which is the square root of negative 1, which we all know is imaginary. So notice as well, if you're a little unsure about whether you have the inequality symbol correct or not, pick a test point or two. See how it looks to you when you try to do the computation. Again, I wrote out the domain in both inequality and interval notation. Let's take a look at letter D. In this case, I wrote a fraction. We have a rational type of function. Not really rational, but we'll call it fractional for now. We'll define the difference later on in the course. G of x is equal to 5 divided by the square root of x minus 7. So now I have two issues. I have a fraction, so the denominator can't be 0, but I have a radical where we can be 0. Well, when it's in the denominator, what we're going to do is just set the radicand greater than 0. So if I just do that here, I'd have x minus 7 is greater than, and I did greater than or equal to just for this piece, and I'm going to fix this in just a second because I probably should have written it the other way in my notes. So x minus 7 is greater than or equal to 0, so x would be greater than or equal to 7. So the domain of the radical is x, the set of x such that x is greater than or equal to 7, which in interval notation is 7 to infinity. However, remember this is in the denominator, and so if this were just the radical, that's what we would have. But actually our final answer actually should be the set of x such that x is greater than 7, or in interval notation, instead of the bracket, we want the parenthesis from 7 to infinity. So again, what's under the radical can't be 0. So our final answer will not include the equal to. It's very, very important for us to make sure we keep straight.